Okay, so this is part 2 of our parts of an algebraic expression. So we had solved 11 less than 3 times the number, 3n minus 11. So really quickly, down here too, remember a sum equals addition. Okay, the difference equals subtraction. The product equals multiplication. And the quotient equals division. Okay? Well, quotient helps if I spell it correctly. Now, notice we had less than just a second ago. So that's something that we might write down that's different, and we know that it's going to be a subtraction. Okay? And so then you might keep going down from there and find some more vocabulary that's related to the operations of our mathematical expressions. So the next one says 6 times times 6 times the quotient of 4 and a number. So remember, what does that mean? A number. Well, that's a variable. So the quotient of 4 and a number, so that's all kind of one thing. And then it says 6 times the quotient of 4 and a number. Okay. So here we go. I'm going to open that up. So 6 times something, and it's the quotient of 4 and a number. So I have to solve this first before I can do 6 times that, because it's the 6 times the excuse me, quotient of 4 and a number. So quotient means to divide. So it could be written as 4 divided by n, and then times 6. And this 6 could come before or after, but it does say 6 times the quotient of 4 and a number. So that is one way that you can write that algebraic expression. Another way that you can write it and that you will see it would be 6 times 4 over n. Okay? Because that means to divide as well. So those are the two ways that you can write that. So 6 times the quotient of 4 and a number. Now, this one, how many terms does it have? Remember, terms are separated by an addition or a subtraction sign. Okay? So think about that. How many terms is that? So now we're going to keep moving. The next one says the sum of 12 divided by twice a number. Alright, so the sum 12 divided by twice a number. Well, I will tell you, this word right here is wrong. Okay? There's no sum. That's meant there to throw you off. And so this is unneeded information. It's 12 divided by twice a number. Okay? So once again, just like above, there's two ways to write this. Okay? 12 divided by 2n, because twice a number, 2 times a number. Or it could be written as 12 over 2 times n. Okay? Either way would be correct. Alright. To the next one. It says a number decreased by 13. Decreased, does that tell me what? What does that say? And notice it's a number decreased by 13. Decreased means to subtract, and so a number would be n, and then this would be the number 13. So this is a number, an unknown amount, a number decreased by 13. A number decreased by 13. Now, remember up here, we had to do it a different direction. We had to do it a different way even though 11 less than came. Make sure that you're reading these very carefully when you go to put them in because order matters with subtraction. Okay? And note this one has 2 terms because it is being separated by a subtraction symbol. So now, using what we know from here, this one right here, now we're going to go and we're actually going to write these numerical expressions, or these algebraic expressions, excuse me, into words like up here. So I have this one. Now, there's multiple ways to write these, okay? And so there's multiple vocabulary that you can use. So we're going to talk about this. We have n plus 15. So I'm going to give you guys a few examples. These are not all of the examples. So this could be a number increased, kind of like the one right above it, by 15. Okay, that could be one. The next one could be the sum of a number and 15. Now remember, there's multiple ways, right? Multiple ways to write that, but that's just 2 examples of how to write n plus 15. So now, the next one, we have 4 times x minus 32. Well guys, guess what? You have an example right up here. This one is very much like that one. Okay? So this is another one. I want to see you answer in words in wisdom. I'm going to put it right here. There'll be a separate assignment for this. Okay, it will kind of be a fill-in-the-blank assignment. Okay, so this one should look a lot like this one here. The next one, we have 3 plus 12 times n. So, this one might look like 3 more than the product of 12 and a number. Okay? 3 more than 12, the product of 12 and a number. There's another way you could write that. It could be the product of 12 and a number increased by 3. Okay, so once again, multiple ways to write that. And notice this one has 2 terms, this one has 2 terms, this one has 2 terms. So then, we have this here. We have 9 times y divided by 3. Once again, multiple ways to write this. So, this would be the quotient of 9 times a number and 3. That's one way to write it. You could also write it the product of 9 times a number, or the product of 9 and a number divided by 3. That's another way that you could write it. Okay? Multiple ways to write these. There's not just one correct answer. Okay? Now, like I said, this one I need to see in wisdom. Okay, I need a response in wisdom, and it needs to look a lot like that one. Just a hint. Okay? So now that we're done with those, we're going to take and we're going to look at this in when we're talking about some word problems here. Okay, because we have some word problems up here that we're going to take and make this work. So, continuing on, I'm going to start with this flap here, so I'm going to turn my notes so we can read it. It says, Hannah is 3 years younger, keyword younger, than Katie. Okay, so we've got Hannah, who's going to be H, Katie, who's going to be K. Got this 3 years, younger than, meaning less than, spam. Okay, and then we have Cody, C, is twice as old as Hannah. Alright, so we're going to start here because we know Hannah, kind of starts with Hannah, we see Hannah twice. So we're going to have H. Okay, so this is going to look like so we've got two things that we can write in here. So notice Hannah is 3 years younger than Katie. So we've got K minus 3 would give me Hannah's age, right? Hannah is my variable. We don't know how old Hannah is. And then we have 2 times H is C, right? So we have two expressions from situations here. So the first expression that is presented is K minus 3, because obviously we're looking for Hannah's age. And then the second one that we have, okay, the second piece of information we have is Cody is twice as old as Hannah. So that would be 2 times H. Twice as old as Hannah. Okay? So there we go. And a lot of times when it says is, okay, that implies an equal sign, but since it says expressions, one thing that we have to remember is an expression does not have an equal sign. So there's two expressions based upon that situation there. Okay? So now we're going to keep moving. I'm going to, well, while I'm still turned this way, I'm going to look at this one. It says Paul scored 23 more, Paul is going to be P, points than his brother Mark in the basketball game. 23 more than Mark. So I could write that two different ways. That's only one expression. So M plus 23, so whatever Mark scored plus 23 would equal Paul's. Or remember, addition is commutative, so it could be 23 plus M for Mark. Okay? So either one would work. Okay, so now this one. Give me just a second, guys. Yes, Dakota. Okay, go lay down and take a nap. On your coat? Okay, so this one says Patrick runs 4 miles per day. So 4 miles per day. Per, okay, usually means to multiply. It says how many miles is he running in M days? So it gives you your variable here, okay? So 4 miles per day, and so we're looking at M days. So if he runs 4 miles in 1 day and it gives us M days, we're just going to write right here, it's going to be 4 times M, because that's the amount of days, that's the variable amount of days that we will have when Patrick runs. So now this one says Angela earned $14 per hour, okay, hour, for babysitting a family of 4 kids. How much did she earn in H hours? Now, the information that we don't need is the family of 4 kids. It doesn't matter how many kids, she's just getting $14 per hour. So how much does she earn in this many hours? So this is another question that in Wisdom you are actually going to answer, okay? So, that being said, guys, I want to do a few example problems with you guys while we're doing this, and it might help you with those 2 questions in Wisdom, and it will help you with your independent practice as well. So the first one that I have for you, we're going to do several different types of examples here. I'm going to get my handy dandy notebook out. Do do do. Dun 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 dun. Maybe. Okay. So if you want to follow along in your workbook, you're more than welcome, but you don't have to tear this page out. So this one here, it says a variable written as a letter represents a quantity that can change. That's why it's called a variable, because it varies. You can use a variable to write an algebraic expression that has at least one operation. So this one says a word or phrase, and this is giving you examples. The sum of 8 and a number a. Okay, the variable is a, you're using addition, 8 plus a. 5 less than a number b. Okay, subtraction, b minus 5, and we did one just like that in our notes. The product of 8 and a number c. Product means to multiply, so 8 times c. And then it says the quotient of a number d divided by 2. So d divided by 2, or you could use the division symbol. So now, it says, number 2, it says identify the variable and the operation in this algebraic expression. So, and I know that's kind of hard to see, it's 6 over x. So anytime it's over that, my variable is x, and my operation is division, meaning 6 divided by x, or the quotient of 6 and x. I'm going to try and zoom this in just a touch. Whoops. There we go. Okay. So then we have vocabulary. It says explain why 15 plus 1/2 n is an algebraic expression. Well, remember the definition of an algebraic expression was it contained at least one variable and at least one operation. This actually contains 2 operations. It contains addition and multiplication. Number 4. Could you describe the expression 2 times 3 plus 4 as a product of 2 factors? Explain. Now, this one, yes you can, a product of 2 factors, because it's called that distributive property. So I'm going to show you what I'm talking about here. It's a review phrase that we have. So we have 2 times 3 plus 4. Now, in order of operations, we would solve parentheses first. And so that would give us 7. So then I would have 2 times 7, which gives me 14. The other way we can work this same problem, though, is we have 2 times 3 plus 4. And we would distribute the 2 to each of the terms in the parentheses. 1 term, 2 terms. So then I would have 2 times 3 plus 2 times 4. Okay, so now 2 times 3 is 6, plus 2 times 4 is 8, and 6 plus 8 is 14. So now the product of 2 factors, because it would be the product, I'm multiplying 2 times a factor of 3 and then a factor of 4. So that's why. It's a factor of 3 and a factor of 4. So that's how you could explain it as a product of 2 factors. And remember, this is the distributive property. Okay? So I'm going to fold that up so we can see this next one. It says, which part of the expression 2 times 3 plus 4 is the sum of 2 terms? So, sum of 2 terms would be this right here. This is the sum of 2 terms. 1 term, 2 terms. Remember, a term is separated by an addition sign or a subtraction sign. Don't forget that. So now we have 5 less than y. 5 less than y. That means we would do, it says less than y. So we have to put y first, minus, because less than 5. Number 7, whoops, I'm moving it over a little bit, sorry guys. It says 6 times, multiplication, the quantity 2x, meaning 2 times x, plus 3 times y, because it's 3y. So what this one looks like, we've got a quantity, 2 times x plus 3 times y, and then it's going to be 6 times all of that. Okay, so 6 times the quantity 2x plus 3y. Okay? So now, continue moving. It says, how many terms does the expression have? So terms. Remember, terms are separated by an addition and subtraction symbols. So like this, even though it has an operation and this has an operation, they are not counted, okay, as two terms. This would be a term, this would be a term, and this would be a term, because there's addition and subtraction. So 1, 2, 3 terms, because terms are only separated by addition and subtraction symbols. It says, which term has a coefficient? Remember, a coefficient helps, and a coefficient has to do with multiplication. So this isn't a coefficient, this is a constant. This one has a coefficient because it helps the variable 7z. 7 is my coefficient. And then it says which term is a constant numerical value, and a constant simply just doesn't have a variable with it. So 12 and 5/10 is my constant. Okay? So that kind of gives us a starting place. And remember, if you guys need some help with your vocabulary and stuff like that, if you'll look at pages 146 in your workbook and 147, it gives you some more examples, and it gives you some other information. Okay, so make sure that you're reviewing that if you have any questions. Okay, so that concludes our notes for today. Make sure that you complete your assignments tomorrow and the next day in relationship to this. Okay, guys? Have a fabulous week, and come back Thursday for another set of notes.